Okay, we can have various numerical descriptors that can be used to describe population. Most of them are either sums of the sample elements or means of them, like average of them. So central limit theorem states that the sampling distribution of sampling mean, it means if you're using sample mean, then its distribution will be approximately normal, not perfectly normal but approximately normal, and the mean of that distribution will be equal to the mean of the population, and its standard deviation will be standard deviation of the population divided by square root of sample size. But if you're not using sampling mean as statistic and we are using sum of the sample elements, then the sampling distribution will have approximately normal distribution. Okay, and it's the mean of that distribution will be n the sample size times the mean of the population, and standard deviation will be the standard deviation of the population times square root of the sample size. But both of these will be true only when n is large. N means the sample size is large. But how large? If the population has a normal distribution, then the sample size does not matter. The sampling distribution will be normal. But if the sample population has a symmetric distribution, then the sampling distribution of the sampling mean will be approximately normal for relatively small sample size. We cannot pinpoint or exactly tell that how small, but relatively small means less than 30 or around 20 or something around that. But if the population is skewed towards one side, it is not symmetric or it is not exactly normal, it is skewed, then the sample size n equal to or more than 30 can ensure an approximate normal distribution of the sampling distribution.